All right, I'm back with part 2 of lesson 1.1. So I was talking about how, letter E, root 10, is just a little bit more than 3. All right, we can't say with absolute certainty that it's less than 3.25, but I think intuition, just like our gut feeling tells us it's probably like 3.1. It's probably not getting a lot bigger that way. And I think that's good enough for this lesson. So it's probably around, somewhere around 3.1-ish. And then the last one for this example is negative root 10. So all I got to do is say, let's do a mirror image of 3.1 in the negative direction. So here's negative 3. All right, it's not quite to negative 3.25, although we haven't really proven that yet. That's letter F. I'm going to throw another example at you guys so that you've got 2 to work with, especially when it's the first lesson of a new class. Okay, doing the same thing again. So let's see what you guys remember on the last video, last example. 3 2/9. I seem to remember something about the ninths. 7/9 was 0.7 repeating. 8/9 was 0.8 repeating. What's 2/9? 0.2 repeating. All right, so that's what I'm hoping you guys start to see these patterns so that you can start to make better sense of things, like quicker recognition of those patterns. So 2/9 would be a little bit less than. It's like 3.22, less than 3.25. So go out to 3. The next tick mark is 3.25. I'm not putting the dot quite at 3.25. It's left of it. And that's our first one. Check that one off the list. Oh, we got a decimal. Good. Those are the easiest ones to compare. Because all we got to do is think quarter, 0.25. Half, 0.50. 3/4, 0.75. And then you just start that trend pattern over again. So negative 4.77, you start at 0, go all the way to negative 4. 1 notch would be negative 4.25. 2 notches would be negative 4.50. 3 notches would be negative 4.75. This is negative 4.77. That means it's to the left of negative 4.75. It's sort of like this. It's like you could look at this as almost like 477. It's like go 477 paces to the left versus going 475 paces to the left. This marker is losing its luster. All right, 2/5. All right, it's got to be a fraction between 0 and 1 because the top is smaller than the bottom. I could put the 2 in the box and just do a pretty quick calculation, but I want you guys to recognize one other thing that you can do. If the bottom is 5, that means we can think about it in terms of something over 10. Because I don't know if you guys remember, but we can always find like a different version of a fraction by multiplying the bottom and the top by something. So if I multiply the bottom by 2 and the top by 2, hey, 4/10 is just another way of talking about 2/5. So what is 4/10? It's 0.4, or it's 0.40. Now, I'll be honest, you guys probably could have figured that out way quicker by just putting the 2 in the box, the 5 on the outside, 0.0, 5 goes into 24 times, bada bing, bada boom. But I like that idea of, using a different kind of pattern. You got 0.40. So, again, 2 different methods. this is 0.50, and this tick mark right here, just 1 to the right of 0 is 0.25. 0.25, 0.50, 0.40 is in the middle of those two. So you just got to put that mark between them. And then I'm just putting a little arrow to indicate that C was the actually what that dot is. All right, 3 more. Root 17. I'm going to erase this for some room. All right, now let's just, let's unpack this one with the square roots a little bit more. I kind of rushed it on the last example because I'm trying to keep those videos to 15 minutes. 1 times 1 is 1. And that's what it means to be a square root. To be a square root, it's what number times itself gives us that root. So it's 1. Yeah? 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And I won't put the whole list of things. I think that gives us a good thing to kind of talk about this. But this just means that root 2 and root 3, and really any decimal root that would be between those two, has to be 1 point something. If it's root 5, 6, 7, 8, it's got to be 2 point something. If it's root 10, 11, 12, 13, 14, 15, it's got to be 3 point something. If it's root 17, 18, 19, 20, 21, 22, 23, 24, it's got to be 4 point something. So we're talking about root 17. That means it's got to be approximately 4 point something. Now, for simplicity's sake, I'm keeping the numbers relatively close to the perfect square. That's what we call these numbers right here. Before it or after it. So then all you got to do is say, it's 4 point something. There's 4. Point something means go a little bit more to the right. And then you got it. Root 17 is to the right of 4. Check D off the list. And we got 2 more, it looks like. All right. Oh, I like this example. So you got negative 13 over 27. Okay. Now some of you guys, I know on the homework you're just going to be like, throw that 13 in the box, 27 on the outside, bada bing, bada boom, let's do the division. I see something. No, I don't need to erase that stuff. 13 doubled. So here's just a thought to ponder, a little thought bubble for you. 13 over 26, that's exactly a half, because 13 is exactly half of 26. So 13.5 is half of 27. All right? I mean, every time you move up 1, half of 1 is 0.5. So compare these two numbers. Negative 13.5 over 27 versus negative 13 over 27. 13 is not quite half of 27. So it's kind of like negative 13 over 27 is approximately not quite half. What is not quite half? What is not quite 0.50? It'd be like 0.5. It'd be like 0.48 or 0.49 or 0.47. It's 0.4 something. Negative 0.4 something. And that something really doesn't matter beyond that. Because all we got to do now is say, I know it's left of 0 on the number line, negative a half. It's not quite, so I got to go right of that. E. All right, just so I don't bore you guys, I'm not going to go through the division, but I think you'll see that 13 over 27 is like negative 0.48-ish. I didn't check that, so. Oh, okay. We got, look, this is tricky. F is negative 0.48. Okay, so, wow, this is tricky. So what we have to do now is we have to ask ourselves, we established that this number was negative 0.4, probably negative 0.48 or 0.49. We got to know for sure what's happening with that hundredths place when we divide right here. So ultimately, I love this logic, and really it should formulate through the brain quicker than the explanation that I gave you guys. But we got to do the division. So we got to figure out if 13 divided by 27 is more than or less than 0.48. So 27 goes into 130 4 times. 4 times 7, 28. Carry the 2. 4 times 2 is 8. Add the 2 to it, it's 10. 30 minus 8 is 22. Drop a 0. All right. This is the question. Is it 0.48 or is it 0.49 or maybe 0.47? So think about it. Well, 10 times 27 is 270. Let's just start taking away ones from there. 270 minus 27. Take away 20 from 270. Get 250. Take away 7 more. Is that 243? Well, so it's not 9. It's not 9. It's got to be, I think it's got to be 8. Let's check it. 8. So 8 times 7 is 56. 8 times 2 is 16, plus the 5 from the 56. Got it. Okay. Oh no, they're the same? Are they both 0.48? The answer is no, because there's still some stuff left over here. The difference between these two is 4. Drop another 0. 40. 27 goes into 40 one more time. That extra digit of accuracy actually gives it a little bit more of an oomph, okay? It's kind of like if somebody said, I have $481 billion, and you're just like, well, I only have $480 billion. That's a difference of $1 billion. So we're talking about a difference instead here of 0.001. That just means that this one is negative 0.481. This one is just negative 0.48. This one needs to go further left on the number line, which means we have to give a little dot that's almost right on smack dab the letter E, but we have to show that it's just to the right of it. And that's letter F. All right, these 2 15-minute long videos for what seems to be a very short process, 2 examples. I just wanted to be extra thorough for you guys just because it's your first Math 1 video, first lesson, so just soak it in. You might not have been totally keeping up with me on sort of mental math calculations, or maybe even some of the reasoning and logic I was using. Just please be patient, and just be patient. Thanks.